Assalamu alaikum dear students. This is Dr. Mohammad Mazharul Islam, Associate Professor of Community Medicine, Bashundhara Ad-din Medical College. Today my discussion topic is independent samples t-test. First of all, let us see what are the contents of today's discussion. We would like to learn about what is independent samples t-test, where this procedure is applicable, how to compute this in SPSS, and how to interpret independent samples t-test. So, what is independent samples t-test? T-tests tell us whether two means are different or not. We are going to compare two means from one measurement of two different groups. For example, mean systolic blood pressure of males and mean systolic blood pressure of females will be compared. Here the variable is same, that is systolic blood pressure. This procedure is applicable in a situation where there are one variable is divided into two subgroups. In this test, we are going to measure one group, that is male, and then measure a second group, that is female, and then see if the mean for males is statistically significant or statistically significantly different than the mean for females. Two groups are measured one time, because each of the groups are independent of each other. We will use an independent samples t-test. Now, let us see how to compute this procedure in SPSS. First of all, we need a data set in which we have already collected data and entered it in SPSS, and we have our variables already in the SPSS. So, first of all, we have to click on Analyze, then click on Compare Means, then click on Pair Independent Samples t-test. Then this window will appear. Here we see the box in the left side which contains all the variables, and another box in the right side that will contain the variable that we are going to compute. For this reason, I have selected systolic pressure. It is a numerical variable, and I have clicked on this and then clicked on the arrow mark. It will go to the right box. After that, we see a box below the right box, the small box that is it says grouping variables. So, below that we see another tab, namely define groups. We have to click on that define groups. After clicking on that, we shall see this dialog box. This dialog box will ask us to define groups. As I have already defined females as 0 and males as 1 during my data collection and data entry in the SPSS. So, I will write down 0 in the group 1 and 1 in the group 2. Then click on continue, then click on OK. If we see the variable view in the SPSS, we see in the sex variable there are two subgroups, one is female, another is male. Female is assigned as 0 and male is assigned as 1. So, this 0 and this 1 I used in the previous box. Now, if we click on OK button, this result will come up in the output view. There are two tables. First of all, we see a table known as group statistics, that is for descriptive statistics, and another window, another table, namely independent samples test, it is for inferential statistics. In the descriptive statistics table, we see there are several columns. First of all, the name of the variable, that is sex. It is divided into two parts, one is female, another is male, and next column is for n, or number of observations. There are 10 female and 1 male in this data set, and next column is mean. We see 116 millimeter of mercury is the mean systolic blood pressure for female, and 130 millimeter of mercury is the mean systolic blood pressure for male. And next column shows the standard deviation, and the last column shows the standard error of mean. In the second table, that is inferential statistics table, it shows several information. First of all, let us see, there are two rows. The upper rows is about equal variances assumed, and the lower row is telling that equal variances not assumed. We are concerned with the first row, that is equal variances assumed. Then we see there is a column showing t value. We know that our t value must be greater than the critical value in the student's t distribution table. Here our t value is minus 1.037, and in the t distribution table we see that in the two tails where the alpha is 0.05 and degree of freedom is 9, as our degree of freedom is 9 showing in the our table here in the inferential statistics, degree of freedom is 9, and so we shall look up for the critical value where degree of freedom is 9 and alpha is 0.05 and it is two tails. So, the critical value is 2.262 and our t value is 1.037. Here we must have to ignore the negative sign and we consider the value as 1.037, our estimated t value. So, we see that our estimated t value is smaller than the critical value in the t distribution table. That means t value is smaller than critical value, it is not statistically significantly different. In the next column, we see significance two-tailed, which will show us the p value. P value here is 0.327. We know that p value must be 0.05 or less to be significant. Here it is larger than 0.05. So, it is not statistically significant. In the last column, we see 95% confidence interval of the difference. We know that it will be statistically significant if it does not cross 0. Here the upper value is positive and the lower value is negative at the different side of 0. So, it crosses 0. So, it is not statistically significantly different. So, we can conclude as all three are telling the same, these means are not statistically significantly different. That is, the mean systolic blood pressure of the males and the females are not statistically significantly different, and this is our interpretation. So, that is all for today. Thank you. Assalamu alaikum.